This question is titled, what is the simplest mechanism of isolation? Because you know that there are very, very complex very isolation-driven mechanisms like virtual machines. You could start up your VMware or VirtualBox or QEMU and have a virtual machine with the Linux installed in it. It would be completely isolated from the rest of your system. But that's very heavyweight. And that kind of isolation is actually somewhat problematic because you do sometimes want to share some files or some services or some processes between the host machine and the guest machine. And if, like me, you are a QEMU user, you oftentimes have to scratch your head and say, oh, what is this 9P mechanism for sharing directories? What is this virtualenv nonsense? Well, it can be difficult to share things in that fashion. In this question, we're going to talk about a very lightweight, very simple mechanism, the mechanism of subshells using environmental variables. And so in this question, we're going to talk about what environmental variables really are, what a virtual environment like a Python venv is or a conda env is, and what we can do with subshells. And surprisingly enough, you're going to notice a lot of this seems really reminiscent of approaches and strategies and thinking that you apply not at the sysadministration side, not at the shell scripting side, but within your code itself. And so, why don't we get started? What are environmental variables? Well, we know there is this command, env, and it prints out our environmental variables, and you can see my pwd, present working directory, my home directory. You can see what my old pwd is. If you do cd with a single dash, it'll take you back to the previous present working directory. That's a little pro tip for you. And you can see there's really not a whole lot here. At the operating system level, every process that is started with a double pointer to a collection of strings that can be interpreted as environmental variables. Now, it's a little bit difficult for us to tease apart what's an environmental variable as provided by the operating system and what's an environmental variable from the perspective of an application that uses libc. And in the Linux world, libc and the operating system are very closely linked, but there's not this necessary implication that if you're using Linux, then you must be using glibc or using a libc. But generally, the way that we interpret this is not just a double pointer to some block of memory that can be interpreted in a particular fashion, but a double pointer to some block of memory that, via common libc calls, we can do key value pairings, look up a key, get a corresponding value, and both of these are strings. And so if we're storing some numerical data in here, like the size of my history file, well, we store it as a string, and then the program is responsible for interpreting it. And so that's why you'll often find when you have programs that take environmental variables, sometimes it'll be like set flag equal to yes, y, set it equal to 1, set it equal to true. And you're like, why are all these different choices? Why isn't there a Boolean type? Well, there's nothing but strings. And so oftentimes programs that take some sort of Boolean flag as an environmental variable just are looking for that key value entry to have something in it, not necessarily to be set to any particular value. Now, critically, environmental variables are inherited from parent processes to children processes, and they can be set at any level. And so here, I can set some variable in my environment and run the env command, and all the env command does is either set some variables and execute another binary, or just print out what your environmental variable is. So you can see the variable that it's set. What I could do is I could run env, and I could sleep for just 1/10 of a second just to let it start up. In that env, I could launch a sleep 1 to sleep for 1 second, and I could look at the process tree. And here you can see my Z-shell process launched this sleep process up here. I need this sleep 0.1 because who knows how long it takes for env to actually launch the process under it, and that might be some number of microseconds or nanoseconds, so I just want to sleep for an iota of time. But you can see there's some mechanism by which a process can start another process. And when that happens, typically, you pass all of your environmental variables down, which means that a program can start a child program which inherits environmental variables, and it can set environmental variables so that the child process inherits those, or the child process sees those. In other words, here you can see I have a shell that starts a shell, and, well, actually, there's actually a couple more layers here, but I have a shell that starts a sleep process, and the environmental variables will be sent downwards. Well, this can be used for isolation because if I have some program and I'm launching that program, you can see, well, it doesn't work when I try and launch this program, when I try and see where this program that I just wrote that's just a simple shell script that does a sleep on. Oh, I need to set my environmental variable of my path for this to run. Oh, there, that's that program. Well, when I launch this program, I can launch it with a bunch of environmental variables, and those environmental variables can control certain things. Now, this implication of libc is a very careful and delicate thing because it is not guaranteed that every program that you run uses libc. Anything that's statically linked may have its own libc-like shim. There are programming languages out there, Go and Rust and Zig, which need some sort of shim between themselves and libc, but where libc is not guaranteed. But largely, the majority of the actual programs that you use day to day are aware of a common set of environmental variables. Path, for how it then goes about finding where executables are. LD library path, for identifying where to find dynamically loaded libraries. LD run path, which is, and CPP flags and LD flags and C flags and CC flags, which are used by the compiler. So sometimes you want to set those so that, if you're using this to build something else, which builds something else, or if, for example, you're using CFFI or C types, which might itself at runtime build code, you want those to capture the state of the environment. Things like man path, when you type man to look up your man page, it actually has a search path. And what this means, if you can set these environmental variables, you can change the behavior of some code. Here, we have just all the environmental variables that we might set in order to change the behavior of some code or some process. Well, this is basically what a virtual environment is, and that's really the limits of it. All a virtual environment is a copy of something that looks really similar to the root level of your operating system, a bin directory, an include directory, a lib directory, a share directory, and judicious setting of the environmental variables in order to tell some process that you run, oh, no, don't look in the actual slash bin, look in my environments bin. And if you need to load a library, don't look in user lib or lib, look in my local lib, and so forth and so on. And of course, this does require support from the underlying application, but most of the applications that you run day to day have fairly well-founded support for this. In the case of Python, it requires a little bit of extra support, like, for example, how does Python construct its own sys.path, its search path? Well, it's going to base that off of looking at where it started itself, so where its binary is located, and then it'll use that to figure out what its search path is. And that's something that the Python developers could have chosen not to do. And then that would break some of this isolation mechanism. But generally, this is such a well-founded principle that these environmental variables can dictate where you go and look for things, that if a program doesn't behave properly when its path is set or when these different environmental variables are set, usually somebody will complain and usually somebody will ask for it to be fixed. Now, there's more than just this. In the case of Python, there's Python path and Python home, and previous versions of virtualenv used to set those as well. But largely, when you go into an environment, like by doing like source bin activate in a Python virtual environment, the only thing that it really does is it changes your path. And it changes your path to include the location for where the new Python is installed. And then Python launches and then picks that up and says, oh, I'm in env bin, not in user local bin or in user bin or in bin. Therefore, if I'm looking for a library, I'm going to look not in user local or in local or somewhere like that. I'm going to look relative to where I started. This is all conda environments and virtual environments really are. It's just a local file folder structure that looks very similar to your root level structure, and some environmental variables to say, oh, don't look over there, look over here. You may be aware of things like truths and jails, and these are very sophisticated mechanisms. Your virtual environments are not even close to that level of sophistication. They really are just limited by environmental level, these environmental variables. Now, one important thing to note is, and this is something that I believe Python's virtualenv gets completely and totally wrong. Whenever we have an isolation mechanism, one of the ways in which we ensure that it's an isolation mechanism is when we're done, it cleans up after itself, and there's a clean and easy way to invoke that cleanup. So for example, in your pure Python code, if you had some variable that you are setting that was a global variable, like x, you'd probably save the value of x, then change it to your thing, and then reset it back to its previous value. You wouldn't just say, oh, x equals 20, because maybe this was set to something some other part of the program needed, and you don't want to interact or affect that other part of the program. So you'll store this value, set it, and then do some work. Or if you're a little bit more ambitious, you might even use a context manager. In that context manager, you might set this. And you might use things like context vars or thread local variables. There's all sorts of mechanisms to support this. Well, similarly, if you had some data and that data is some kind of lookup, you might use the collections.chainmap. Because here I have a dictionary, and I have some value that I can look up in that dictionary. Maybe I want to change this, but I want somebody to be able to undo or rewind this. So I could set something in this chain map after appending a new layer to the beginning, because a chain map is not one dictionary, it's a layering of dictionaries, and it looks through those layerings to find the first instance of a match. And so here I add a new layer, then I set X in just that new layer, then I add another new layer, and I set X in just that new layer, and then I could pop off these layers and see that I effectively rewound myself to the earlier state. And that's exactly what we want. We want some sort of layering so we can set some state and then immediately back out. Well, here's why I think these environmental tools get it wrong. They always have some script that you source, and you always have to deactivate by doing deactivate, but that's not the way it's supposed to work. Instead, what you should do is you should do something like set an environmental variable and invoke a subshell. Because you can invoke your shell from your shell. And if I look at my PS tree, I'll see, oh, I'm actually in a Z shell, within maybe even another Z shell, within my tmux environment. Here, I have access to this X variable, but if I exit back up to the higher level where all of this state doesn't exist anymore. And so I can easily set some state and enter an environment, and the moment I'm done, I can Control D or exit and clear that. And it's a very nice context manager-esque way to enter and exit a context. You've seen this before. Here's a nice little pro tip. When you're working with your colleague who knows everything about the shell and they're teaching you all sorts of commands for how to run something, here's a nice little trick that I like to do. Before they start telling you all the commands you want to run, set your history file to something, maybe set it to something like some notes, and then execute a subshell. And then they say, oh, you type ls, you type pwd, you type free, you type hostname, and when you're done, Control D, and you will have set your history file just for that local session, just in that one case, to this file, which will contain all the notes of all the commands that you just ran. And so you can have a nice little listing of all the commands that you ran as part of that interactive session, and you don't have to take notes on the side. You don't have to slow them down and say, hold on, let me write this down. I could just use something as simple as that. Now, I don't really use conda environments or virtual environments. I use them to set up the environment because I don't want to copy everything over into that file folder, into that folder structure. But I don't use them to activate the environment because largely I actually work in in environments that have more than just Python. They'll have Python code, they'll have code in other languages, they'll have code that I've built from source that's in C or C++ or Rust or Go. They'll have JavaScript code with node modules. And so many years ago, I wrote my own tool for managing in virtual environments. And I called it PNV, and it's on GitHub, and it has no documentation whatsoever because the less documentation you write, the fewer users you have and the fewer headaches you'll have. Well, what PNV does is it really boils down this idea of environment-level isolation to its core most basics. Basically, if I have a couple of directories that I create, and you can see I created a little directory structure here, dir, bin, include, some dir, some other dir with a bin and include in each one of these. Well, what I can do is I can use PNV to create an ad hoc virtual setup where it uses both of those directories. So what I could do is I can actually install all my Python code into one directory, all my Node code into a different directory, all my other C code into another directory, and I can construct these layers myself by just setting environmental variables with my PNV tool. And I can scope that to a single command. So I don't have to activate, run some command, and then deactivate. I could easily write shell scripts that just say, go into this environment, do one task, and then come right back out. And one thing, and by the way, if you want to see how this works, you can kind of see, it just added these two directories there. One thing that you might note is the way in which variables are interpolated is they get interpolated before the command gets run. So if I do env x equals 1 and env y equals x plus 1, when I run this, I'm going to see both x and y are set to 1, not set to 1 and 2. And the reason for that is this interpolation, this evaluation happened when this command was, prior to this command being executed, prior to this environmental variable being set. And so when y is created where x doesn't exist, and so by default with this mathematical operator it's set to 0, and so I'll see x and y are equal to 1. If I wanted to be able to set an environmental variable based on the state of another environmental variable, which is very, very common. Think about it. When you are working with Node or NPM, you have that Node modules directory within which you have a bin directory, and that contains scripts that were installed as part of your npm install process. Well, wouldn't you want to use a program like npm in order to tell you where that bin directory is and then set it as an environmental variable, and then based off of that maybe set some other things? This is actually pretty common. Well, what you'd have to do is you'd have to set the environmental variable, then in a subshell you could look at that state of that environmental variable and then run another one and another one and keep going deeper and deeper and deeper. And this is basically what penv does for you. Without that many levels of subshells, it allows you to set environmental variables based on the set of previous environmental variables that you set. So you can construct very complex combinations of take the stuff from this directory, the stuff from this directory, and the stuff from this directory, and set some environmental variables based on what you saw, and construct an environment where you can run your code easily. The reason why I think penv is such a cool little tool is it's about 80 lines of code in Zshell. The majority of it is just little cute features that I added just to make my life easier, but it works flawlessly with the virtual environment mechanisms with NPM, the virtual environment mechanisms provided by conda, the virtual environments provided by the venv module in the Python standard library, and you can mix and match them. And at its core, it shows that this level of isolation is very simple, very lightweight. It doesn't move anything around. It doesn't copy anything around. It's just about setting those environmental variables to set search paths that most programs are aware of and follow when they go about looking for where a binary is, where a linked library is, and so forth and so on.